All right. Good afternoon, everyone, and welcome to today's webinar on patenting AI with the expert from Pearl Cohen. My name is Gideon Mendels. I'm the CEO of Comet. We'll start by introducing you to Cometml and Pearl Cohen, and then to today's speakers. So Comet is a meta machine learning platform designed to help AI practitioners and teams to build reliable machine learning models. And we do this by streamlining the entire machine learning model lifecycle. We work with some of the biggest companies in the world, and we help their teams track, compare, explain, and reproduce their machine learning experiments. For the next slide, I'm inviting Caleb Pollack from Pearl Cohen to introduce Pearl Cohen today. Caleb, please go ahead.
Good afternoon. This is Caleb Pollack. Pearl Cohen is an international law firm with offices in the United States, Israel, and the UK. We represent high-tech or innovation-driven clients from Fortune 500 companies to small-cap companies and startups. We provide our clients with a range of services from IP to corporate to litigation and other services tech-driven clients like these need.
Great. So I'm really excited to introduce today's speakers, who are really one of the real professionals in this field. So I'll start with Caleb Pollack. Caleb is a partner in the patent design, patent litigation, and post-grant proceedings group at Pearl Cohen, New York's office. He manages and prosecutes utility and design patent matters for large and small clients, advises clients on worldwide patent prosecution strategy, and conducts post-grant proceeding, including re-examinations and IPRs. In addition, Caleb drafts licensing agreements, non-infringement and invalidity opinions, and manage intellectual property due diligence projects. Caleb's practice encompasses a wide variety of technologies, including microprocessors, cellular telephony, communications protocol, medical devices, mechanical devices, anything from complex three-dimensional printers all the way to barbecues, internet security and commerce, and computer software and AI. Prior to joining Pearl Cohen, Caleb was an associate at Kramer, Levin, Naftals, and Franco LP, and Kenyon & Kenyon, both in New York City. We also have Milo Eadan, who is a senior patent agent in the patents and patent litigation and post-grant proceedings groups at Pearl Cohen's Los Angeles office. He concentrates on patent prosecution for high-tech and analytical systems in the field of software, artificial intelligence and machine learning, neural networks, encryption and security, virtual and augmented reality, wireless and GSM protocols, computing networks, smart and IoT devices, tomography, and computer modeling. Prior to joining Pearl Cohen, Milo conducted research at MIT Neuroscience and Astrophysics Lab. And last, I'm Gideon Mendels, CEO and co-founder of Comet. Before starting Comet about 2.5 years ago, as a machine learning researcher at Columbia University, where I mostly worked on speech processing and NLP. Additionally, I spent a few years building deep learning models, both at Google and at GroupWise. So for today's topics, we're going to spend the next 30 minutes or so, we'll be talking about the following. So we'll start with some background and growth of AI patents. We'll talk on some of the challenges when obtaining a patent, how to make the process actually successful. And finally, we'll walk through a few case studies of what is likely versus unlikely to get patented and why. And of course, at the end, there'll be a time for Q&A with our experts at the end of the webinar. Right, so really, one of the reasons we decided to do this webinar, and we're really excited to have Caleb and Milo here, is because we've seen working with our customers and teams on how challenging it is to kind of navigate through the AI patent world. So just to give you an idea of where we are in terms of patent activity, as you might imagine, things have increased significantly since 2012. One interesting point is if you see the top curve is China's filing levels actually overtook the US in 2014 and has maintained high growth rate. And this is very correlated to what we see on platforms like Archive in terms of publication papers. Additionally, in terms of companies, IBM actually has the largest AI portfolio in terms of patent families. Microsoft has a second spot, followed by a few companies in China, and then only Sony and then Google. In terms of the trends, this shouldn't surprise anyone actually working in the field. we've seen kind of steadily increase over the time period in this chart. So this is starting in 2007. In terms of relative change, one of the interesting points here is there's a 4.4-fold increase around natural language processing, or NLP, patents. And then the largest absolute difference with 2217 filings is associated with computer vision. So really, these are the key indicators or trends we're seeing in machine learning success, where modeling actually works. So it's no surprise we're seeing a lot of patent as well. But now I'm actually going to turn it over to Caleb, and we can talk about the key considerations and when working and patenting. Caleb, please go ahead.
Thank you. Yeah. So I'm going to talk to you about a few of the main things that you should be talking about with your patent attorney when you want to patent an invention. These are just sort of the highlights. Your attorney should be handling these details, but these are things that you should know that you should talk about. First of all, a patent must provide enabling disclosure, which enables one skilled in the art to make and use your invention. In other words, you need to provide some how-to or details, or a lot of how-to and a lot of details. Now, this requirement is rarely enforced in and of itself, and it's highly subjective, but providing detail and enabling disclosure will allow your patent attorney to overcome other barriers to patentability, which I'll discuss a little later. You will get a substantive rejection, almost definitely. Almost definitely the first thing that a patent examiner will do a few years after you file your patent application is issue a rejection based on prior art. Prior art are documents that show what's been done before. So the patent examiner will attempt to show that your invention has been done before or is obvious in light of what's been done before. Now, this is in part due to two things. First of all, the patenting process is to some extent a negotiation. So no matter how new, no matter how inventive or groundbreaking your invention is, the patent examiner will likely issue a rejection based on prior art. The other reason this happens is that your patent attorney's job is in part to define your invention as broadly as possible in order to capture as many potential infringers as possible. And this attempt to your benefit by your patent attorney to define your invention as broadly as possible bumps up against the examiner's job, which is to try to find prior art showing that someone made your invention before. So what happens is you'll get a rejection, and the patent attorney will respond to it by redefining your invention maybe a little more narrowly, providing arguments. There are a number of ways to go about it. Another important concept that you should be discussing with your patent attorney is your priority date. This is the date of your earliest filing, such that prior art documents, publications, etc., dated on or after your priority date can't be used against you. So you want to file a patent application in order to get as early a priority date as possible. And this priority document, your first filing, must provide enabling disclosure. In other words, it must provide the appropriate details how to make and use the invention. One way of obtaining a priority date is to file a provisional patent application. A provisional patent application is basically a quick and cheap patent application which doesn't have to comply with many of the formal requirements of a regular non-provisional patent application. The thing is that provisional application, as I said, must provide enabling disclosure. It must provide enough detail so that one skilled in the art can reproduce your invention. And provisional patent applications can be a little deceiving or give you a false sense of security because of these reasons. For these reasons, you get out of a provisional what you put into it. So if you don't put enough time or energy into drafting a good provisional application, it might not support your priority date or what you think is your priority date. And the thing is, you won't know about this until years later, years after the filing of your provisional. When a patent examiner takes up examination or when the case gets to court, that's when you'll find out that the provisional application you filed years ago didn't provide enabling disclosure, didn't have enough detail. So could you go to the next slide? Another concept is that a patent application filed in one jurisdiction will apply only to that jurisdiction. So if you file in the US, if you get a patent, you'll only get a patent in the US. You'll have to file in other jurisdictions to get patent protection in Europe, China, etc. People often ask us, inventors coming to us with ideas often ask us, should I do a prior art search? And we, to some extent, recommend against it because the cost of conducting and also analyzing a search can be a significant portion of the cost of the patent application itself. And while a search can provide some good information, a search cannot be 100% complete. There's 10 million or so US patents. There's no way the best patent searcher is going to be able to find all possible prior art in those 10 million patents. And a patent examiner is entitled to cite against you patent or documents, patents, printed publications in any language from any era. So if there's a Russian academic paper published 10 years ago that describes your invention, there's no way that a conventional US searcher is going to find that. So the search is going to be inherently incomplete because searches are both expensive, never definitive. Large corporations generally don't perform searches. They file their patent applications and allow the patent office to do the search, which is perfectly legal. You're not obligated to do a search. If you're a smaller company, if you have one invention which is going to define your company, one potential patent application, you may want to actually do a search, keeping in mind the limitations of the search that I just described. You may want to do a search to see whether you should adjust your business strategy, not file for a patent, file a patent in a different manner. But you have to bear in mind that it's not usually done and it comes with some costs. You can go to the next slide. So there are a number of hurdles to obtaining a patent. The two key ones that are applicable to AI and neural network inventions are that the invention must be new and not obvious over what's been done before. That's intuitive. But also that the invention has to have subject matter eligibility. This means it has to be in the category of inventions that are appropriate for a patent. Separate from whether or not something's been done before, the courts and the law and Congress have said that certain types of inventions are simply not appropriate for patenting. Now I'm going to give you the cites to the laws and court cases that are relevant here, not because I expect you to actually remember it, but rather this is the terminology your patent attorney and the patent office will be using. So that an invention must be new and not obvious over what's been done before is governed by 35 U.S.C. 102 and 103. An example of this is putting an existing off-the-shelf AI speech recognition interface in a car. It may be obvious. Even if it's never been done before, this sort of thing may be considered obvious. Doing the same thing and at the same time solving some new technical problem related to this is hopefully non-obvious and patentable. Subject matter eligibility is relevant to the AI area because as a practical matter, most AI and neural network inventions are embodied in software. They're expressed in software when they're used and when they're presented to the patent office as an invention, even if the invention's an algorithm. So the relevant law here is 35 U.S.C. 101, and the main Supreme Court case here is Alice. In 2014, the Supreme Court came down with its Alice decision, which upended and for a time restricted the type of software inventions that could be patented. In the aftermath of Alice in 2014, 2015, the Patent Office almost stopped issuing patents for software inventions. This has steadily improved since 2014 as the lower courts defined the Alice decision and explained it, and as the USPTO issued guidelines that gradually allowed patent examiners to issue more software inventions. So one way, looking at the next slide, one way to to answer the question, is my software patent going to be patentable? Is it patent eligible, separate from whether it's been done before? Is to put the to put the invention on an unofficial continuum. This is a continuum not in any law, but this is a practical matter where different types of software inventions lie and how patent eligible they are. And if you'll notice, I expressed how patent eligible software inventions are using the term what is likely to be considered patent eligible. And this is because this area of law is highly subjective. The court cases are confusing, and it depends a lot on which patent examiner you get, which art unit, which is a division within the patent office you get, or which court you get. So the least patent eligible are pure business methods divorced from any sort of technology or software. This is the one category of invention that the court has said is simply not patent eligible. And I know you guys aren't doing business methods, but business methods are often discussed in the same sentence as software. Software that's less likely to be patent eligible than other types of software, but for which we have gotten patents for some of our clients, is software or technology that operates business methods, commerce-related applications, social media, organizing human activities, scheduling people's work. This is less likely to be patent eligible, but we have gotten some patents for our clients in this area. Software that should be more patent eligible, but which still faces these Alice 35 U.S.C. 101 rejections, is software which is tech-heavy and solves a non-commerce problem like image processing, but is connected to physical technology only by a general-purpose computer. Software that's more likely to be patent eligible is software that's intimately tied to some physical process other than the general-purpose computer, such as communications protocols that control your iPhone. Software that's most likely to be patent eligible is software that improves the computer itself, such as branch prediction in a microprocessor, which is effectively firmware. So moving on to the next slide. I'll describe the different categories of AI and neural network inventions that we see, and then apply it to these different levels of patent eligibility. One type of neural network or AI invention we see is using an existing off-the-shelf AI application for a new application, for a new result. Another type of AI invention we see is software that trains or executes or is used in the training or executing of a neural network. And the third type is a new neural network architecture. Now, applying these to the different levels of patent eligibility, using existing off-the-shelf AI for a new application and software that is used for training or executing a new neural network could be considered to be in this middle category of stuff that's technology, but it's not connected to the physical world other than on the conventional off-the-shelf computer that executes it. Software that might be in a, oh, can you go to the next slide? Thanks. Software that is intimately tied to a physical process and therefore is more likely to be patent eligible may include using existing off-the-shelf AI solutions for a new application if that application controls some physical process. This also might include a new neural network architecture. Now, neural network architectures are typically, when they're implemented, mathematical constructs which are implemented on a general-purpose computer. But your patent attorney could frame it as being a physical process because it's because your patent attorney might refer to the neural network architecture, which, while abstract, could be somehow considered to be a physical thing. Similarly, a new neural network architecture could be considered to be in the most patentable category, most patent-eligible category, excuse me, software that improves the operation of the computer itself, because a new neural network architecture, even if it's an abstract set of matrix operations, is meant to improve computing. Similarly, software that trains or executes a known neural network, inventions regarding that kind of software, could be software that improves the operation of the computer itself, and could be expressed this way because it's meant to improve the operation of a neural network, which is a computing construct. So, as I said, you're likely to you're most likely to get some sort of rejection. The question is, what can your patent attorney do, or what can you do in advance to, if not avoid these rejections, give your patent attorney the tool to overcome these rejections? There are a number of things. One, looking at the next slide, is to, as I said before, put as much detail in your patent application as possible. Can we move to the next slide? Yes, thank you. Even details should go into your patent application, even if they are details which are known to everybody in the technical field, or which are part of the prior art, which have been done before. While the patent law says you don't have to put what's known in your patent applications, as a practical matter, examiners like to see it, and the tools that your patent attorney has to overcome examiners' rejections rely on things being in the patent application that have been done before, and also details about the invention itself. This is just the nature of how inventions are defined, as you'll see in some of what Milo is going to talk about. The way inventions are defined often includes reference to what has been done before. Your invention, even if your invention is in your head an algorithm or an abstracted neural network, your invention should be expressed as much as possible in the patent application as technology and physical computing devices. Both the general purpose computing device on which the software will execute, but also as modules within that software. Even though the modules aren't really physical, your patent application should have diagrams showing modules, different software modules. This is in an effort to express your patent application, or your invention, as much as solid technology. Lastly, just because of the nature of the arguments that the Patent Office recognizes as being valid arguments for your invention being patent-eligible subject matter, your patent attorney should include in your application how prior art methods are improved by your invention. What technology benefits from or is improved by your invention. Now I'll turn it over to Milo, who will provide some specific use cases.
Great. Thank you, Caleb. So I'm going to describe some concrete examples of what constitutes patent-eligible subject matter at the USPTO. So the Alice decision that Caleb discussed ruled that the mere automation of ideas or abstract concepts is not sufficient to meet the threshold of patent eligibility. And in this field, that essentially amounts to the fact that generic neural networks applied to conventional algorithms are not likely to meet the threshold of patent eligibility. So I want to explore with you what is sufficient to pass that threshold test. Our first case study comes from a recently patented invention that we obtained in the past month or two. And in considering whether or not it meets patent eligibility criterion, we want to look at the items that Caleb discussed, which are, does it solve any problems? Does it provide any improvements to technology or to the computer function? So this invention is directed to the technique called sparsification or pruning. This technique was developed to address the growing need as these neural networks become more and more massive and the data sets used, solve them become larger and larger. So to make neural networks run faster, groups and developers have invented this idea of pruning and to cut a lot of the unnecessary weights and synapses between neurons. Now, while that speeds up the processing, it doesn't really decrease the data storage. So in practice, these neural networks and their weights are represented in large matrices. And to prune or cut a synapse amounts to zeroing weight field in that matrix. So what you end up is you have giant matrices with many, many zeros. So these are multiplied very quickly, fast processing, but they still require a huge amount of storage space to store essentially zeros. So the inventor in this case created a new way to store weight information instead of in a matrix as a triplet. So each weight is associated with an ID, the from neuron and the to neuron, to uniquely identify which weight it indicates. And the benefit of this is that that each weight isn't defined by its position in a matrix, but by its ID, so you no longer need to store all of these zeros. The initial disadvantage of now you have more data for indexing is vastly outweighed by the benefit of eliminating the need to store all these zeros. So the memory in sparse neural networks compresses quite substantially. If you could go to the next slide. I wanted to look at the claim, how we put this invention into words. And this is the main claim of the recent patent. The first line, called the preamble, is really not given much weight, but is really used to describe and color the invention. So a method for efficiently storing a sparse neural network. We put in this preamble a nod to the examiner. We're showing the examiner that the goal of this is to improve the function of the computer itself. This neural network has an effect on the storage structure, and we're flagging this to the examiner. The next limitation, the first limitation, the obtaining step, is really just to describe the structure of a neural network. This is all old. A neural network comprises weights. The weights connect neurons. The neurons are organized in layers, and a minority of the neurons are connected. That indicates that it's a sparse neural network. The invention is found in the last limitation, which is how the computer stores this neural network. And it is by using unique indexing of the weights, where you only store non-zero weights and you don't store the zero weights. So this is a very broad claim, and the way we were able to get through the patent office is we targeted the criterion for patent eligibility that Caleb described. So the preamble is the flag to say, this is a flag to an examiner saying, hey, we're addressing the criterion laid out in the Alice decision, that this is an improvement to the computer. The body of the claim in the storage step explains how we're implementing that efficient storage. And if you go to the next slide, in the specification, and the specification is the written description of the patent application, where you provide the enabling disclosure, describes and quantifies the improvement. So we explain that while burdening memory with all these new indexes, we are ultimately reducing the total memory when your neural network is sparse enough. And we give a metric to quantify the improvement. And this makes the improvement, it gives evidence and credence to the improvement, and it makes it irrefutable by the examiner, because you can point to a value and it can't be ignored, as opposed to simply saying, if you were to simply say this makes the computer work better, that would carry less weight. If you can find a value or a quantifiable measure, that carries much more weight. So some tips and we have from this case study are that we want to focus on the problem, problem and solution, that we're decreasing the storage, decreasing the storage problems associated in this field, that we provide an improvement to the function of the computer itself. We're decreasing storage, and that allows us to increase the speed and efficiency of the computer. We've quantified that benefit. In the preamble, we've indicated to the examiner that this is what we're going after. And the way we conveyed this story is by having an interview with the examiner. So when we got a rejection, we, within our right, after the issuance of a first office action, we are able to telephone the interview and tell them this story. And this is good for a number of reasons. It lends a human voice and a personality to the negotiations, but it also minimizes admissions on the record. Everything you put in writing can be used against you when going after infringers. So you want to say as little as possible in the written record. We could go to the next slide. So the second case study is a hypothetical. This is the, in Caleb's spectrum continuum of patent eligibility, this is the low and the less likely to be patent eligible subject matter. And what this comprises are the use of off-the-shelf neural networks applied to conventional, non-technological fields. So if we were to take an off-the-shelf neural network and use it for natural language recognition, for example, to detect the meaning of speech, you could imagine that this is very similar to what we as humans do every day as we communicate. We use our brain, the neural network of our brain, to detect the meaning of speech. And the Alice decision held that merely implementing that on a computer instead of in ourselves does not amount to patent eligibility. So the first one would likely be, or is less likely to be, patent eligible without some new trick, either to improve speed or the accuracy. The second use case includes several red flags, things that our examiners see as less likely to be patent eligible, that is using neural networks for marketing, advertising, social media, where you discover what to sell, what to show in advertisements to customers. Another application is using neural networks for scheduling, either staff or tasks. These are considered methods of organizing human activity, which are considered abstract. And abstraction is on the far end, the opposite end of patent eligibility. So if we could go to the next slide, this represents the other extreme on Caleb's continuum of use cases that are more likely to be patent eligible. The first class of cases are directed to inventions that improve a technological field. So if you use neural networks, in this example, for self-driving cars to improve a braking system. As an example, the system can use neural networks to detect a new movement type, and that can make braking more accurate. That improves a technological field. And the Alice decision held that that was more likely to be patent eligible. The second class are those inventions that provide improvements to the computer itself. I just made an example in which you have several neural network passes. Maybe the first pass is a superficial one, and if you get a positive result, triggers a deeper second pass that would result in faster, more efficient runtime than if you did a standard conventional single deep pass. So that would make the computer more efficient. It would get your result faster. And the way I like to imagine it is if you had the improvement to the computer itself is if you had two identical computers on a desk, and you program the left computer with your conventional neural network that completes a standard algorithm. This is just simply the abstract idea, nothing new. And then you program the right computer with your inventive software, and you let them run, and you set a clock. Does your software complete faster? Does it complete using less memory, or more efficiently? And that's a way to see that while it's software, it changes the nature and the function of the computer to make the computer on the right operate as a different machine. And that really transforms it into patent-eligible subject matter. So all these things are considerations that should go into drafting a patent application. You should be, like Caleb said, discuss them with your patent attorney. And as discussed, there will likely be a rejection. And if you're in the software field and you're using neural networks, there's very likely going to be a 101 patent eligibility rejection. So you want to have some ammunition, an arsenal of improvements and different disclosures in the specification that you can use to rebut these rejections when they come. Thank you.
All right, Caleb and Milo, thank you so much for this thorough overview. We would love to take participants' questions right now. So we'll give you a few minutes. If you click on the Zoom bar at the bottom, should be a Q&A section, and everyone should be able to ask questions. We'll give you maybe like a minute or two to submit some questions. There's already a few from earlier in this talk. I think one of the most interesting takeaways, at least I have from this, and really on the last slide there, is when it comes to the second type of patent eligibility use cases as in improving a process for those who are using AutoML solutions to essentially encompass everything in a black box. It's going to be very, very challenging. And as Milo said, you want to have as much ammunition as possible, which kind of makes the point of building your own models a little bit stronger. But again, feel free to ask any questions on the QA side. We have a first question from Dmitry Chiryev, who's asking that basically is asking a lot of what we're seeing in the slides and this talk is the work of the patent attorney that needs to package it as a patent eligible case. So how does this information affect us as engineers or machine learning researchers?
I'm sorry, can you repeat the question? I'm sorry.
Yes. Yeah, no problem. So the question is, a lot of this, the work you presented around patent eligibility is that the attorneys work on building a patent eligible case. What Dmitry is asking is how does this information affect him or us as machine learning engineers? What do we have to take into account while building these models?
Yeah, right. So the information that we were trying to provide, it wasn't meant to affect your inventions. You come up with technology however you come up with technology. With how the legal aspects are not necessarily what you should be concerned with when you're developing technology. We were providing this information so you go into a patent relationship informed. In other words, when clients approach us, we like to give them some realistic feedback of what they can expect, both in terms of success. We don't want to, if someone comes to us with an invention that is likely to be held not patent eligible, we want to tell them that. We don't want them to have unrealistic expectations for success. Second of all, we want you to have expectations about what the things that you're going to have to talk about with your patent attorney. In other words, if your patent attorney doesn't ask you a lot about details, I guess, be suspicious. That's really what you are supposed to do with the information we're giving you.
Great. Thank you so much for your answer. We have another question about if you can comment on how these patent eligibility criteria and considerations play out in the EU, the European Union? Is it similar or completely different?
There are some overlapping similarities. I should say, though, that both Caleb and I would say, if we spoke about this, we're not European patent attorneys, so we can't really accurately, or we can't say that we are very familiar with the law. So we would coordinate with the European patent agent. There are similarities to drafting. In Europe, they use a problem-solution approach. So it's very important to the European Patent Office in obtaining European patents that the invention solves a particular problem. And this was for years ignored in the US until the Alice decision and patent eligibility criterion came up. And so now we're more coordinated with Europe. So that's a big overlap. I have to say, in practice, usually, so the equivalent to patent eligibility in Europe is that that the patent office requires that the invention be tied to a certain machine, and I think that generally there's a very simple way in Europe to get over this, which is just to put in the words computer implemented in your claim. This seems to satisfy their requirements. So I would say that the US threshold for patenting software is higher. That is, if you'll meet the US threshold, you'll be fine in Europe, most likely.
And I would add to that, like Milo said, we do have, we work closely with European patent attorneys who are in our office or in our firm. And so if you want to contact us directly after the talk, we can get you a more direct, a more comprehensive answer from our partners at Europe.
Great, thank you so much. Another question, what due diligence regarding prior art should we have done as inventors before engaging a formal patent search, assuming this is a small company for which the search makes sense?
If your question is, should you do a search before a search? I'm not sure that you really need to. I mean, there's a number of different ways to go about searching. One is to simply do your own search using the Patent Office website. The thing is, there are some sort of pitfalls for the uninitiated. And another way is to commission a formal search, which can cost on the order of $1,000. A professional searcher will come up with a search report. You might want to do both, just I guess to keep your professional searcher honest, to make sure that the stuff you came up with isn't so much better than theirs. But I'm not sure that there's any sort of search that you need to be done before engaging a formal patent search.
I just want to make one comment also about self-searching. So these proceedings are ex parte. They are by one party with the Patent Office, the examination. So there is built into the patent system an ethical obligation that all parties involved in the patent have to disclose what they find to the Patent Office. And that includes we as patent agents and attorneys. It includes inventors. It includes anybody involved with the company. So if you do a search and you become aware of something, we have an obligation to provide that to the Patent Office. Theoretically, it'll create a stronger patent because once it's vetted by the Patent Office, it's now printed on the face of the patent and you have their certification and stamp that your invention is patentable over it.
Thank you. Another question is if you can provide some examples of recent litigation cases of US AI patents.
So actually, off the top of my head, neither myself nor Milo can come up with an example, but I think that might be because AI patents, first of all, are relatively new, so they might not have been litigated, but another reason is that they might be so patent eligible, so much towards the type of patent that is likely to be patent eligible that courts haven't had to opine on this. Courts generally issue opinions on the hard, the hard cases, the middle cases where reasonable people could disagree. It may be the case that AI patents are so clearly patent eligible that nobody has thought to attack them as being patent ineligible.
All right, thank you. Another question, and of course, you can try to answer it on a general level, and feel free to pass. One of the questions is how much money should we budget for a search and for patent drafting?
For a search?
For search and drafting, yes.
You know, I would say these are all on the order of questions. They could vary, and also bear in mind, to a large extent, you get what you paid for. For a search, there's two components to the search. One is having a professional searcher do the search. We prefer to have a professional searcher do the search. A patent attorney can do the search as well. That might be on the order of $1,000, $2,000. And these are people who are typically not attorneys. They just know how to search for patents and other literature and other publications. Then you need to interpret it. And the thing is with patents, unless you know what you're doing, trying to interpret a search may lead you down the wrong path. So you probably want to have your patent attorney do the search, which could cost on the order of, again, it could vary greatly, $1,000 to $2,000 in legal fees. That's just, again, on the order of. Patents to actually draft and file a patent in the US in the AI area is on the order of, let's say, $9,000 to $15,000 when you include the patent office fees. The USPTO fees are about $900 if you're a small entity, if you're a startup. But again, that can vary. I'm sure you could find someone who will give you a lower price, but again, you get what you pay for in this area. And bear in mind that includes the US only. If you want to take that US patent and file it in Europe, that could be an extra several $1,000s. You don't have to rewrite the patent, but you have to engage a European patent attorney and pay European patent office fees.
Great, thank you so much. So we have one last question here, but if any one of the participants have more, now is the time to add them to the QA section. This one is discussing the challenges of really patenting in AI, and maybe asking about maybe we should focus what's on top of it. So I'll read the question as is, but if you have any clarifying questions, feel free. So what they're saying is, we think about patent eligibility, is it's more useful to focus on the UX design, for example, for a computer vision tool, versus attempting to patent the underlying technology itself, given that it's almost always a familiar machine learning technology. And if that's the case, what's the best way to think about the UX design in terms of what to focus on with respect to patent eligibility?
If by UX you mean user experience, I believe that's what you mean.
Yes.
I would say no. I mean, I hope when I was talking about patent eligibility, I hope I wasn't scaring people off. There are barriers to it, but these days, if you have a technical AI invention, it's more likely than not to be patent eligible. If you have an e-commerce invention, it's less likely to be. It's more likely than not to be patent ineligible. So, and then the user experience, that, depending on how you express it in terms of a patent, is less likely to be patent eligible than the technical aspects of some new AI paradigm, some new software paradigm. You can get software patented. It's just that there's an additional barrier to software patentability that can usually be overcome if it's a highly technical invention, but it's a barrier that you have to be aware of exists. Thank you.
So we have one last question for today, asking what type of questions does an attorney ask a client to get more information or details about the invention?
Yeah, so there are a few things that need to go to a patent application. Like Caleb said, you need to provide an enabling disclosure. This is the real basis of everything. You need to describe to a person of ordinary skill in the art how to make or use the invention. This is a blueprint for the invention. So, you know, as engineers, you're educating your attorney in your particular technology. So if you can convey to them and to a sufficient basis that they can understand it, that should be enough to provide an enabling disclosure to a person of ordinary skill in the art. The second piece is that to preempt obviousness rejections, to preempt patent ineligibility rejections, you really want to address those prongs we discussed, which are how does the invention solve a problem in a technological field, and what kind of improvements it makes in a technology or to the computer itself.
Thank you. One thing I will add to that from someone who's been on the other side, an engineer trying to file for a patent, I found the process very similar to writing an academic paper, a white paper, essentially describing into depth everything you did and how, essentially in a reproducible way, which is what we're hearing from Caleb and Milo as well. And then from there, that starts a kind of deeper process. But from your side, you can expect to write something like that in that amount of detail. But with this, we would like to wrap up the Q&A section. We would like to thank you, everyone, for joining us today. The video and recording of this talk would be sent as an email follow-up after this. So you can go back and see anything you weren't sure about. And additionally, I'm sure both Caleb and Milo would be happy to answer any questions. Their email is right here. Or if you're looking to file a patent application, you're welcome to reach out to them as well. And yeah, thank you again, everyone, for taking the time. It was a pleasure having you here, and hope everyone have a great day. Thank you, Caleb and Milo.
Thank you. Thank you.